Hi, in this session I'm going to cover a concept of projectile motion, which basically comes under uh, chapter 2 of mechanics under the subtopic motion. So what we need to understand that mostly what happened that this projectile motion, student usually struggle with the numericals. So before I actually start the projectile motion over here, I want you to understand one thing, that before we actually talk about projectile motion, students have already derived the equation of motion, which I am writing here for your reference, that v is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2s. Sometimes people also call them Suvat equation. So projectile motion is basically a case of two dimension, and if we talk about projectile motion, there are a few things which we need to understand. If I draw my diagram over here for a projectile motion, because projectile motion simply says a body which is moving under the influence of gravity. So if I throw something with some initial velocity u, and it is making some angle theta, which is my projected angle with the x-axis, I need to understand one thing, that this particular motion is going to be happening in this way, that this object will go like this. So you can notice something over here, that the whole body is moving under the influence of gravity. And in physics we have a very basic rule that whenever you wanted to solve any particular concept, the value should be given on x-axis and y-axis. If you notice this particular case over here, you can simply see that your initial projected velocity is present in the plane. So what we need to do for that part, we will simply draw our component over here, and when I draw my component, means I need to get this value of u on x-axis. For that I have drawn a perpendicular x-axis, and I need to get this value of u on my y-axis as well, so I have drawn a perpendicular on the y-axis as well. So according to the concept of resolution of vector, we know that the component of velocity which will come adjacent to the theta, it is something which is always written as u cos theta. So I will write it here for you, that this component is u cos theta, and the component which we have opposite to the theta, like this one, it is written with the angle sine, so it is u sine theta. Now there is few more things which we need to understand about this particular motion, because as you can see this, basically when this object is going to be moved under the influence of gravity, we know that gravity is something which is acting on y-axis. So I will show that my gravity in every single case is acting downward, because the force of gravity is something which nobody can ignore, nobody can deny, and it will always be pointed towards the center of the earth. So this is how my gravity is acting. Now there's one thing which you people need to remember, that whenever we do questions on projectile, we need to understand that the component which we have on the x-axis, this component which I will highlight it, this component, it basically does not have any influence of gravity on it, because gravity is having its influence on y-axis. So what will happen, no matter where the position of the object is, everywhere your y-axis component is something which is going to be changed, but your x-axis component which we have over here, it is going to be constant for throughout the journey. By that what I am trying to say, that the value of u, which I have said the initial velocity on the plane, its component ux, which we have written as u cos theta, everywhere that u cos theta is going to remain constant. And if somebody says why exactly, why do you consider this u cos theta as constant, you need to understand one particular thing over here, because we don't consider air resistance for our projectile motion. So your air resistance is negligible. That is the reason you don't have to consider any change on the speed which we have on x-axis. So your air resistance is negligible. That is the reason your horizontal component which I have written ux, which is u cos theta, it is going to remain constant. So that should be your reasoning. If someone says that why you are considering u cos theta as a constant, because you are not considering the influence of air resistance on x-axis component. Okay. Now on the other side, if you actually notice that your vertical component, which is u sine theta, you will notice that your u sine theta is something which is exactly opposite to the gravity. Means initially what will happen when the object is going up, because of the influence of gravity, your u sine theta value is going to be decreased. So one particular point where the value of this vertical component, which I have written as uy, as you can mention, this is uy is u sine theta, which is a vertical component. The vertical component of velocity is going to become 0 at a specific point, which we call when the object will attain its maximum height, because at that point your object is going to change its direction. So that is the reason. Always remember that wherever your vertical component of velocity is 0, you will say that is the point which you consider as the maximum height of the object. And after that, what will happen? Definitely it will change its direction, and you can notice that the component of velocity will come to the other side, and then it will keep on increasing, because definitely when it come back to the surface of the earth, whatever the velocity you have initially by which you have projected the object will gain the same velocity when it hits the ground. So this is what you need to remember whenever it comes to the projectile motion. And if I have to specifically tell you like which are the things which we need to remember, so here in this case, if we have to specifically tell you, there are two axes, x-axis and y-axis, and I want to be very clear that you should never get confused with the values on x-axis and y-axis. Let's say if I ask you what is my velocity on the x-axis and y-axis, you need to understand on x-axis the velocity which you have written is u cos theta, which is definitely constant because we don't consider any influence of air resistance on it. On y-axis, if you consider your initial velocity is u sine theta, which is going to be variable, so let me write it as initial velocity over here. Then the second thing which I can comment is the acceleration. So what you need to understand here is this: acceleration when it comes to x-axis, you have said that u cos theta is going to remain constant, and when speed is going to remain constant, that means your acceleration is 0. But on the y-axis, as you have seen, that the gravity component is there, and that is the reason your speed is initially decreasing and then increasing. So remember, your minus g is going to be present on y-axis. If I write the third quantity over here, which is also interesting, if I talk about displacement. Now look here, what will happen when it comes to the displacement on x-axis. Definitely I can see that object has covered some distance on the ground, and let me tell you, this distance we can write it as a distance, or sometimes we mention that the range which has been covered by the object on the ground, which is denoted by r. So basically on x-axis your distance covered is r, or your displacement is r. In this case it is going to be r. But when it comes to the displacement on the y-axis, this is something interesting, because displacement, as you know, that it is a vector quantity, and in this case when you notice on y-axis, object goes up to certain height h max, and then the same object come back to the surface of the earth. This is something which is happening on y-axis, because we are only talking about y-axis displacement. So both the thing are going to be hm, but as displacement is a vector quantity, going up is taken as positive, going down is taken as negative. That means if I add both these values, I am going to get my answer as 0. So you have to be very careful about the values when you are going to plug it in the Suvat equation, that your acceleration is going to be 0 on x-axis, your displacement is going to be 0 on y-axis when object come back to the same position from where you have projected the object. Okay, so we have written velocity, we have written acceleration, we have written displacement, and let me tell you, if we talk about time is something which is, it is going to remain same no matter where the object is. It is something which is independent of your axis. So if we have to calculate any particular question on projectile motion, the first thing I think which we can get it for any situation is the time. because time can be calculated from the x-axis also, and the same time can be plugged on y-axis. Time can be calculated from y-axis also, and the same value of time can be plugged in on x-axis, and we can get the various quantities depending on the question. Thank you.